Hello, everyone. Welcome to the broadcast. Today, we're continuing our game dev project. We are still working on the rendering process. We've got it switched over to a multi-mesh rendering pattern, and it is saving us a lot of rendering performance at high object numbers. But now we've got to figure out how to get the sprite sheet animating, and there's a couple of wrinkles to that. We shall see how it goes. I see Avatar is already joining us. Hello there, welcome. Let's check in with the kitties real quick. We do have Ember over there on the side of the desk. We have Sammy up in the cat tree because Sky has taken her spot on the bed. Mason on the gray comforter, and Sky on the pillow. We'll see how that unfolds. Okay. So I do have a shader set up. Currently it's doing nothing. But longer term, you're thinking Sky, Avatar. Sky was, he had some damaged claws. And he's doing just fine. After a couple of days, he recovered nicely. So one problem we face with this is that the mesh that results from just using quad mesh directly is upside down because it is a 3D mesh, and a 3D mesh uses a different coordinate space. So we got to fix that. And one possibility is this thing right here. If we can get... Is there a way to get the mesh from this? Probably not. Because that's do the thing. It's like that. It's like that, Avatar. Self-modulate. Extends a canvas item, but it is not in and of itself a mesh. So the problem is this uses 3D coordinate space, and it is going to... it's going to run afoul of that. Hello, Ember. Hello. Yes. So is there anything in mesh we can do to force it? Because this will be the first thing that we have to deal with. Orientation is which way it faces. It needs to face Z, which is essentially the camera in this case. Flip faces would make it left-right mirrored, but we also need it. We need it top-bottom mirrored. Because again, the texture 2D wants to take space, and Y positive is down, X positive is right. A 3D space y positive is up. That would be a massive shift in the code there, Avatar. Everything we've got right now is sprite math, or essentially 2D pixel math. .3D creates all kinds of wrinkles. Is there anything we can do with the quad mesh itself? In this case, it's primarily that y is down that we're having the problem. Because if we could flip its coordinate space, we'd be set. In theory, the scaling is one of the things we could do for that, but it doesn't seem to respect that value ultimately. What if we go into ready? Can we get away with that? Yes, we can. Haha. Negative. We essentially inverted the y-axis. Hey there, Parakeet. So, Parakeet, the thing that we are working on right now, so we've got the... This is a bit hacky. This is not actually what we want. That is -1 times 6. There we go. So now we need to get it so that they are rendering properly. So this is at 5,000. We can see that the physics frames are kind of choppy here. That's okay. I think that's ultimately okay. We are getting some blur off of these. I don't know why it's rendering these off kilter like that. I mean, it might be what's happening right now. Not getting an error state. There aren't any unused projectiles anymore. We were creating way more movement objects than we should have, though. Oh, that's because we're instantiating... Okay, I think... mesh render when we... It's the entity manager. When we add an entity... there's a point at which we are culling them down to maximum. Here we go. This should... Yeah, this is culling the movement objects properly. That should stop at 5,000. Okay, we've still got one mouse object stuck to us. But that's at least a start. I think we have a visual instance that isn't correct here. Oh. Actually, no. On the renderer in process. Do... Okay. Okay, instead of orbiting, let's just get them to fly in random directions here. Still one stuck. I don't know what that hitch was, but it just created a pile of entities. Or at least it tried to. This should be the entities going away as they hit the edge there. Or them timing out. I'll have to figure out what's going on with the code here, because we are... clearly having an issue. Hello, Drew. Yeah, we're creating a whole bunch of entities when we shouldn't. We aren't actually going through the entity pool anymore, but we're going to make it flow accordingly. Hey there, Donnie. Welcome, welcome. I do not, but it's a matter of frequency of interaction. We have some visual instances that aren't going away. Let's at least... So these entity visuals aren't going away. And then we got another spike of them being created. But this is the only place that they should be able to get in. Let's catch them before here. So if they get into this collection, we will append them. But until then, like, we'll intercept them before they go in the collection to add, if the number is too high. We'll have to figure that out, though. Be back in just a moment. Sorry about that. We're back. Okay, so we're constantly adding them to the entities to add. So I think we're running into some conflicts here. So we're gonna take this. So this is going through and saying if it's not already there. We're just making sure it gets cleaned up. No, entity pool is a legacy of the pooling system. It's just a vector that everything talks to. It's vestigial at the moment. It doesn't actually do anything other than just kind of relay stuff along for us. But it encapsulates some of the add-remove functionality. So we'll eventually deal with that. Okay, so then when we try to add an entity, right now, hello, Sammy. Else. Base. Entity. Okay, we're going to intercept it here as well. Otherwise, one of the things that was happening is it was piling up. We still have the lingering rendered objects here. And we were still getting a whole bunch created. They are piling up. All right, we're going to need to add some metrics in here too. Because that didn't change anything. Space. Manager. Entities to add. Size. I think I answered. Hey, doing okay, Drew. Doing okay. And hello, Zane. Okay, we have no entities to add. Big hitch, and then a whole bunch of movement objects got created. What's going on with the movement pool anyway? Why is that happening? Because we shouldn't be pooling anything. Hello, Garrett. Welcome. We're working on our game. Oh, we are pooling movements. So we're always going to do this. Tall format is pretty picky about whether people are watching or not. So this number will climb. So this is creating movement objects that... This is a bad sign. At on ready. Needs to be an export if we want to get that. Render be a variable. Let me tell a type there. Well, they shouldn't be able to have zero velocity, Parakeet, because the random direction one asserts a direction. As in, it's not dependent on anything. It just picks essentially a clock face and sends it in that direction. But the fact that they're smearing implies that the visuals are hanging out. Process. Okay, it's each visual array. Thank you, Garrett. Let's take a quick opportunity to look. That's a possibility, Parakeet. So the two that I can think of are it's rendering visual instances that aren't there. We're spawning instances that... Oh. that's actually a possibility, is because when the thing is initialized, it is it should be setting itself into the visuals. But then if we're releasing it right away, let's look at that. Add it to the entity manager right away, and we return it. Then the spawner, after it... Okay. It goes here. Yeah, 1 second. I have 5 cats. They're not always all visible. So here's the problem. We try to add it to the entity manager as soon as we instantiate it here. So then entity pool is not going to call it there. We're going to go into the spawner. Ready to spawn. Let's spawn. We have the spawned entity. Where are we initializing it? Right there. This is when it comes into existence. As soon as this happens, we have an entity. I haven't checked it out. I've heard of it. So here's part of our problem. Is spawning an entity might not work because we can't add it. So we could ask, can I spawn? In the ready to spawn marker, we could just delay it. Should continue spawn loop. Yeah, cloning it just creates another instance of the entity template that is just before we actually create it. It's the initialize that puts it into the world, more or less. Yeah. Okay, let's go into the entity manager. Going to say Boolean. And max entities. Boolean that is false. So what we're doing is we're making a function here. This isn't actually terribly safe, but we're going to do it anyway. There's mutex locks around this, dealing with this guy. So this isn't accurate at all times. Well, thank you, Strawberry. Okay, so spawner. So we get a physics tick. We're going to come into should continue loop. This means they're infinite, or oh, but we don't have access to the mesh renderer here. Move that up. No, entity manager is correct. No, that's correct. Entity manager has space. Space available. Well, that's not right. You're getting into there, and then in... Nothing's ever getting into here. Plus. That's still not quite right. Let's make sure we've got this all. Still not moving. Yup. It's never reaching here. Which is weird. Let's check something here. Okay. Okay, we're never adding to the entity manager, that's why. There we go. Okay, because we were adding them to the entity manager, they were being initialized, so they were being put into the world, even though we were going to reject them right away. Okay. Let me do a quick commit here. So the case that we're dealing with in this is that we're adding a border case for things are going wrong. There are too many things. We are going to need to revisit this logic probably a lot, because the spawner needs to properly recognize that it should not spawn something. It's technically not the end of the world if we get something into the ad collection and it goes over the limit by like 1, because this limit is going to be well beyond where we need to be. Shader. After I get done with this commit, then we're going to look at the shader again. That's where we get into some weird territory. Want to lose any work? Okay. Now, one of the fun things with Godot, here's how you edit the shaders. One, if you'll notice, C-style syntax. Completely different syntax, completely different variable types, that kind of thing. Even semicolon terminated. Hey there, Mimi. Welcome. Let's see. What we want to do. So currently, you can see we're rendering the entire sprite sheet, and that's not what we want. We want to render only the active part of the sprite sheet. For the time being, I only want to render a small portion of the sprite sheet. But how to do? So one of my thoughts was to do... So this is... The syntax is weird. This is going to be a whole learning process getting this done, because syntax and variables are weird. So I'm saying right here, set the color of this pixel equal to referencing the texture, using the texture assumed variable. So we're saying get a value from the texture, using the texture that is that we're dealing with, and then use its UV value. But the UV value is not an actual... This is a vector containing the position on the texture we're dealing with. So doing this does nothing. This says set this pixel equal to the color of this pixel in the texture. So right there. Same thing. It's always the same. But if we then do, I think it's color dot blue is equal to 1. This should blue shift it. But it didn't. Why did it not? Why is it making a liar of me? We do have the shader loaded. We go into the renderer. In ready, we set the shader. Oh, we have errors. Oh, semicolon. Oh, semicolon. Blue shifted. Is that what we want to do? No, but it demonstrates the point. I get the color from that spot, and then I set its blue value to 1. I max its blue value. So instead of getting the point on the texture that we're actually dealing with, I want to get the point on the texture that is related to the actual sprite frame. So in the case of, and we're going to have to add some variables to bring into this thing, which will be fun. One possibility is that we animate it based on its position in the world, which might be a way to kind of hack this, is have a particular amount of space in the world correspond to a frame of animation. So as the thing moves in the world, it will look like it's animating because the sprite frame will pass over time. Now, the tricky part with that is that we have to make sure that you don't get like overlap, because the position in the world is the position of the pixel in the world, which would be flaky. So we might have to come up with some way of setting the shader information instead, is to set like a time variable on this so that they all tick accordingly. We'll see. We'll see. Okay, but this UV value is the actual right. Yes, time. Position in the world would be nice because it would give us a way for each sprite to individually animate. So every instance of it could animate differently, but we might not be able to do that. Sorry, gotta step away again real quick. Be right back. And we're back. Okay. So UV is a two-float vector, a two-dimensional vector, where each of the values is from 0 to 1, which is a fraction of the size of the texture. And we can get the texture size, which is an inverse of the actual size in pixels. Which we know is 1 divided by 6 divided by 4 high, so 64.0. Okay, we're going to reduce this further. That was not correct. So what we want to do is we want to constrain it, is the thing. We want to take this UV value and say that it is actually the percentage of the first sixth. The upper left corner of the sprite sheet. We need a vector 4. Texture is okay, no, vector 2. Divided by 96. It is apparently very picky about syntax. Very, very picky. Shader compiled correctly. Oh, we're close. You have some air cases in there. We're really going to need to work on clean shutdown with the thread. So 16 is too small. "32 is too big." Other way around. Okay, so where is this number coming from? There we go. Frames. It is. We're literally using 1/6 and 1/4. Right there. Float int. We have to explicitly use a decimal place. Okay, it's not times 2. Plus. That should get us down and right one. Yep, that's walking. Okay, so now we know with the shader, we would need to tell it which animation it's using, because that tells us how to manipulate the Y value. Right there, this plus is what jumps it into the right position. So we would need the animation frame. We could determine using time or another variable that we pass in. We can pass in a value that can be set on the shader. So we could have a frame tick set up. I wonder if we can use the world position truncated in some way, but there's a risk. There's always a risk with that. So it needs to be some portion of 6, but it needs to be consistent. It needs to be absolutely consistent across the entirety of the sprite, that we would get the right value. Because I'd love to use world position, but we might have to use time. Time is seconds since it started, and it rolls over at 3600. So every 6 minutes it rolls over. I think we were doing like 6 frames a second. Okay, so time is definitely afloat. So by multiplying it out by 6, we are getting frame slices here. And then we can truncate it down. We want to do this. It is contraindicated in the terms of service of the Nanotype to in any way ingest or taste any part of the Nanotype. If you find that you have done that, accidentally or intentionally, please contact Poison Control and the Catbot Corporation. Then proceed to stand out in front of your home or in front of an open window of some kind, and Catbot Corporation operatives will be there to deal with the problem. So we flatten it into an integer. And then we're going to do modulo 6. No, modulo. Okay, so that'll get us from 0 to 5. We are making a bullet heaven style game, so the sort of game that Vampire Survivors is. That should be 1/6 of a second. Times 6. Let's remove that. There we go. We are animating. We can see that the physics slows way down. Seven, 8, 9, 10. Okay, we're still going to have to refine how movement works, but we knew that. That's a big cost. 10 movement objects at once creates a huge burden on the physics loop. That's why we're getting this ticking lag here. The tick, 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 tick. So visually, we're updating at 30 frames per second. But the physics tick is having to do 5,000 iterations 30 times a second. So it's choking up on that. We have a couple of extra movement entities that we shouldn't. So another way to view it, press start, is yes, the entities are causing the lag. But this is something we're going to have to clean up. The core movement handling, I think, needs to be moved out of Godot so that it can happen faster. Let's do a quick commit check here. Okay, so now we need to get those default values in. We need to mess with the shader. at iteration here. That is supposedly a thing people run into. Press start. If you have enough subscriptions, apparently every now and then YouTube culls some of them. I don't know why, or I don't know what the actual mechanism is. But making sure that you are subbed and that you have notifications turned on, that kind of thing. Okay. So, in the mesh render, for each mesh instance, we add a sprite animator. At this point, we know what the sprites, we know what those values are going to be. There is a way to set values on a shader. Essentially, it's a constant at the time that it's created, and we have to set it in the script. Take a quick look and see if this documentation has what I need. Okay. Parameter of that name. Okay. Not that one. This one. Okay. Okay, so we go into the shader. Int don't know if this will work fully, because we need to be able to have a animation state to determine which one of the animations we use. Guns. Not the best naming convention, but as a float times that. 1 divided by 6. This is essentially a constant. Is equal to 1 divided by float relations. Let's see. Okay, so now we need to have set that later. We need to set these values. For each shader. It's actually tricky, because if it holds still, that's relevant to each individual instance. How are we going to do that? Check this again. Okay, the only one that we care about... The only one that we care about holding still is the player. Everything else doesn't actually need to hold still. And as such, the player would have a multi-level sprite. Don't 100% like that, though. Let's get this logic in here. Animations is size dot divided by wrapper frame size y. Okay, and then we are going to use the same general syntax here, but it's going to be for animation, and we're just going to set that to 0. Okay, so now we have the objects are moving as they should. We can reduce the number of them to really show this. Game ready. Player inventory that does that, I think. Oh, okay, it'd be in catalog. So 5360 here is set to be just bonkers. Let's revert it to its natural state. So if you look, they all animate together. Now the trick will be can we change this value gracefully? Again, I'm fine with like enemy sprites always animating as if they're moving. So in renderer. Those. So this does our scaling for us. We need to keep this for each one. So we're keeping the mesh here. So we're going to add the shaders too. We can use the screen position. And actually, Yeah, screen position could give us a way to animate more gracefully than time, actually. I'll need to think on that for just a moment, but shader materials key to shader material. Okay, so then when we're processing, as a shader material, shader materials key. That's a possibility, Parakeet. Let's take a look at that in a moment. So we need to have a way to assert the animation. And I think that will have to be in the entity, setting it in the texture wrapper. Int. Then in the entity, the end of its move, so ideally it will happen after navigation. We'll get there. If target movement, then visuals dot animation to 1. If texture wrapper dot size dot y divided by texture wrapper size y. This is a needless calculation. We'll figure out a better way to do that later. Yeah, we only need to do this once. Wrapper animation. Oh, wait. It's not texture wrapper. Dang it. It's entity visuals that needs it. Okay, so this is trickier. Because we'd be messing with it each time. I don't know that this will actually do what we want. So we're going to move. Yeah, lots of extraneous stuff going on here. Visual. Okay, we have the movement now. Now we'll need to flip it, though. So there's a lot of extra processing that we don't need to be doing right here. Because we need to get an entity visual. Let's take this, move it back up here. We'll take the very first one. And say they all share that visual. So the risk with screen X plus screen Y parakeet is if the entirety of the sprite crosses a threshold there. So if some portion of the sprite stretched over a modulo number, went from 1 to 2, because of the composite, it would tear the sprite a bit. It'd be by a small amount, but it would create kind of a smearing or tearing effect. How to flip the sprite over. Because we can't scale it. And we want it to be we're setting the instance values. Yeah. I don't think the scaling factor... Oh, no. Let's actually scale it, though. Yeah, scaling factor doesn't impact the transform. So if we say 180, this should flip it over. Yep. About negative 180. Same thing. Avatar, we're not going to do the Deltarune stuff. The same reason I took down the Undertale streams. The company that manages Toby Fox's music puts... it's not a copy strike, but a copyright claim on pretty much any use of the music, regardless of how it's used. So even if they shouldn't be copy claiming it, they do. Which is irritating. Is there? Rotation, scale, skew. Okay. Oh, 2. Zero. Vector, vector, vector. There. Oh, skew is a float. Thank you. Okay, that flipped it upside down. It's not really what... Oh, excellent. Well, thanks for swinging through, Levi. Thank you. Doing okay. We're making some progress today. U of 1.0, comma 1.0. Okay, so we need to have a flipped property in the entity visual. Be right back. Sorry about that. We're back. I see Toji has joined us. Hello, Toji. Okay, so we're not going to use the facing if it doesn't rotate to face. So then in the entity, hello, bottle caps. Welcome. But x is less than 0. True. Elif. Cookie clicker can be kind of addicting. There we go. So we do it this way. Because it preserves the flipped state if we just stop moving. So then in the render, we look at the visuals. And if we don't rotate to face, if entity visual flipped, then scaling dot x -1. Oh. Scaling. Okay. Question is, blobs are working too. I mean, the collision isn't working at all because the entire system for that has changed. But we can see how the blobs change their facing as well. Each individual instance changes its facing. We have made progress today. Made much progress today. Let's see. Yeah, right here, we need to make sure... We need to make sure in the player's process here, because if we clear them, but there's still a distance check, then there is problem. Well, let's do a quick commit here before I lose track of it. Okie doke. That to turn. Zero. We'll just be explicit about it. Here, we're correcting an error case. There we go. Commit of that. All right. So we still have movement processing is a border case that's the problem. We need to have more efficient handling of that loop. there are things that would be cleaner in GDScript, but I think ultimately, because of the amount of processing that happens, even very simple functions are causing a slowdown there. So getting that stuff converted over so that it's swift, I think will be important, but there's going to be layers to it. Like, we might need to create a sort of movement bundle object that will do the iteration for us. And then within that, it's a C library that will actually go through, iterate over all of the movements, and either return a position value or just set it internally. I think returning it will be the cleaner value option. So one of the next things is, hey there, Minty. Welcome. Well, we got at least an hour to go before we wrap up, so you're definitely in time. So the next thing, as far as zones are concerned, is collision handling. And there's some more layering to that. So one way to do it would be to have some area 2Ds and handle it as I was handling it before with collision zone. But the difference is, instead of entities, I could have a couple of aspects here. Is one, an entity would have its collision data, which is just its position and its shape index. As of the time that it received it. So that collision zone is keeping track of those entities and saying, like, okay, I've got collision data that is just a position. It might have some other information to it, like the size of the entity for collision information like that. We might pass some of that in. Essentially the hitbox of the entity. So we have that in a collection. When the area accepts it, it will take that information, it will grab the next available shape index, and it will assign that to that object and make it active again if that shape is available. Otherwise, it's going to create a shape. So if there are no shapes to give it, it creates one, gives it that index. Henceforth, whenever there's a collision, it will call the entity that is the owner of that collision information, which will probably be will probably have a callback in it. So when the entity hands off its position object, when it creates it initially and passes it along to its corresponding area, or that it gets passed along, the entity will be stuffed into that as well. When the owning entity goes away, when it triggers its remove me, the collision area would trigger its own remove function. Which means a collision zone can still be handed an entity, and that entity will then be bound to it, but the entity itself still needs to have it. Okay, we create the entity. The entity creates its initial collision handler object. It subscribes to that collision handler's collision happened event, and then then that collision handler object will be passed along to a collision zone, which will subscribe to that collision zone's remove event. Okay. So an entity shape does not extend class name entity shape as a variable, as a position, is a vector 2, which is a shape, index, which is an integer, which is equal to -1. As an owning entity, so anything that listens, it says, hey, remove that. We'll have to figure out how the collision is actually going to be handled there, because we're going to be able to get the entity shape by its index in our collection. We'll have a dictionary of entity shapes, and when an area has a collision, it will look at the shape, the collection of shapes, and say, this was, you collided. It will then ask the other area to give it the entity it collided with. So, function. It's a signal. Okay, so when an entity is created, it instantiates one of these and keeps a reference to it. It will subscribe to the collide with signal. That. So the owning entity subscribes to this message. When it gets a collision, it knows it collided with this thing. When the entity goes away, it sends the remove signal, which the collision zone will have subscribed to. The collision zone will look at the shape index that's there, disable that shape if it's greater than, -1, if it's at least 0. Put that shape index in a pool of reusable shapes. We don't want to mess with the shape indices. That was one of the fragile points of the prior system, is if we removed an entity, we needed to remove that shape, because the entity contained the shape. We don't want to do that. Instead, we keep the shape around in the collision zone and just disable it. We don't collide with it. Yeah, that should generally work. Okay, so when an entity is initialized, so our visuals, so we create a shape, and we're using rectangles. Navigation is using a circle. We'll do circles. So we'll create a circle shape, we'll set its radius. In the collision zone, we do this. So we're going to set the radius in this. Not doing that. Doing that. Make sure we get that in there. Is an entity shape. So we've got our entity shape ready. Initialize. We're going to check set position being set to nothing, that we disable this function. We might still need to use it, though. Visuals is created outside of it. Shape can be created inside of it. just going to set this to 8 for now. We're using as few nodes as possible now, Avatar. We can get up to about 5,000. Oh, to make the background object is one big node. We just, it's like a tile grid or something like that. We don't need the owner object. Yeah, we don't need the owner. Oh, no. So, we want a collision zone to be able to report which one of its entities collided. So, it needs to be able to get the owner out of its area and supply it. Yeah. See, I think we could wait till set position now to update these. This way, we know that all the position variables are set. It depends on how you structure it, Avatar. There's a whole lot of variables to account for as far as like how all of the nodes are composited in such a thing. At a minimum, you're probably going to have one per player, one for the server, and then probably one for each like connected person. And that's bare minimum. You could have more complex scripts, you could have various layers of nodes. This might have to be a little different, though, thinking on it. Because when the shapes okay, no, the collision zones can iterate on that. Collision zones can look at all of their positional entities and say, what's the current position? Yeah. Yep. Oh, set position. So okay. When the entity creates it, now we need to take the entity needs to handle collisions. So when it creates its shape, we connect the on collision event. That to here. If shape applied with dot connected on collision, then disconnect on collision. Send your remove signal. So we say get rid of us, like remove us from the system here. Then remove our visuals. Then remove our collisions. Ordering of that might need to be tweaked. Effectively, we're approaching collision in the same way we're approaching visuals. Is we want to have the collision zones handle everything about it and only have the entities worry about updating the positions. The entity can handle its collisions by itself for now. but all the collision area knows is like, hey, there's an active shape, here you go. Maybe we'll have logic for telling the collision area to start and stop colliding on a shape. Say, disable my shape, enable my shape, start, stop colliding kind of signals. That way we can handle iframes even more gracefully, just by saying don't collide with this at all. So then a collision zone, we have add entity. We're going to have, we call it in the mesh render, we call it add visual. Okay. Okay, so we get an entity shape in. What's your question? And hello and welcome. I do not play Roblox. It is after my time. Hey there, Tabby Cat. And thank you, Casey. Kitty cats are dodging. Take a look at camera 1 for a moment. Sherbet has shifted over there. If Oh, no, we don't need an if. If we got into here. If we got into here, we don't need to check if we're connected, because the only reason we got in here is that we were connected. Then, if shapes contain find the shape is 0, So then we... So the shape will tell us what the index was. And then we can add that to a queue of available shapes. Hey there, Erebus. Well, good to see you, even if only briefly. It's Ember, not Ash, but, you know, adjacent concept. And it's Ember is female, Sherbet is male. A couple of folks swinging through, so let's check the cameras. We can see 5. We can see all 5. So Sherbet across from the keyboard, Ember on the table next to me, then Mason, Sky, and Sammy on the bed. So Mason's on the little gray comforter, and then Sky is laying on top of Sammy on the pillow there. Sammy has very limited tolerance for Sky's nonsense. Ember allows herself to be bullied by Sky, but Sammy won't. Do not add entities. We may need to deal with that, but we'll find out. Keep physics tick around. I'm making a Bullet Heaven style game. So, player moves around, fires projectiles everywhere, blobs or enemies appear. You know, ideally the player doesn't get touched by them. We are in the stage where we're handling core logic. We still have a lot of refinement to do, but we've actually gotten it to where we can have several thousand things on screen at once. Well, in the world at once, without it slowing down substantially. Like, this is really good. We're at, like, a couple of thousand objects. Let's actually strain it a little bit more. What happens if we do this? I haven't tried this in a bit. For science. Ah, look at it go. Just racking up. Then we hit our limit. Now we can see that the physics is stuttering, but that's 5,000 objects on the screen, and our rendering speed hasn't dropped. And movement speed is still holding pretty well. Look at all of them. Not sure yet, Casey. Not sure yet. For performance optimization, we're probably going to reach a point where we have to have some C libraries, and C libraries do limit where it can be deployed. I think they can still work in the Android compile, but I'm not certain. And we're going to release on Steam first if we reach that point. That's our first target. But that target is still a ways off. But let's see. Oh. Further stress test. Load items. Move that burst. 25, 125, 625. 625 objects being created at once. Oh no, my math was off. That's a lot more than that. 5, 25. No, that's right, isn't it? Oh, that should be correct. But we're creating way more than we should. Must have mathed that wrong. We've got that lingering little guy right there that is clearly broken. That's way more than it should be creating at once. And we do get that one lingering one. I wonder what's going on with that. No, but the reason we use burst 1 there is that so, actually, yeah. Oh, that's why. Because there's 6 of them. Yeah, we were creating like 3,600 objects at once. This is 30 objects at once. So if we then take that, do that. So this will be 25 at once per weapon, so 150 at a time. With the numbers being skewed because there are blobs being created. Okay. So this is 750 at a time. We do have a pretty substantial case, and we still have like a lingering entity being created. I think that might be due to us hitting the threshold for entities being created at just the wrong moment. Because it can hit a threshold there. So we might be creating it when we're not supposed to. Yeah. You're back. Okay. So clearly we still have some stuff to clean up here as far as entity spawning to make sure we're never spawning something when we shouldn't. But that's, I think, updating the spawner to play nice with the entity manager logic. Entity manager is a new thing, comparatively. There's a lot of refactoring that's going to happen in the near future. Double check. Okay. Made a little interim commit here. So then when a collision zone it's an add shape request. Array of integers. So like that. If indexes size is greater than 0, index is equal to open indexes pop back. We're going to do pop back so we don't have to slide the whole array. Move me. Act. Shape remove me. Just so. Physics server. Shape create. Set data shape. Oh, entity initialize. Set data. Entity shape, radius. I thought we had our area, local area already. No robotic voice. No female presenting voice. Set it in advance. Area, add shape, local area. Shape, position. Okay. Area. Area RID. Okay, so for those of you that aren't following the stream of consciousness, we are in the process of converting our collision handling over to a kind of a disjoint model where the game entities will have a effectively a collision shape that they hand off to the collision handlers. Those collision handlers will in turn take that object and inform the the original entity when a collision happens. And much footwork ensues. Okay. So we've got that. We have enabled the shape. Set shape disabled. Indexes append. Index. Just to be sure. We clear its shape index again, just to be sure that it's gone. This is a dictionary. Me, and then add shape. Hey. Shape remove me. Should be right. All the collision zone. spawn, we're going to add an entity to it. Oh, we've already created it. Okay, so when we spawn, we have initialized it. Shape new entity dot. I really want to be reaching into it that way. I'm gonna have to anyhow. This presumes something about the internal working. So instead, we are going to have we're going to have to sort these two. And done. Spawner, instead of target zone, we're going to say new entity set collision zone target zone. Okay. Okay, we're never getting collisions there. Hey there, RM. That kitty is Ember. She is the smallest and the second oldest. Let's see how many others we can see here. We can see 4 out of 5. So we have Ember there on the table. We have Sky on the gray blanket. We have Mason on the tan blanket. And then Sammy on the pillow. Not visible is Sherbet, though Sherbet has been hanging out kind of above the bed camera there. is shape index 0. So add the shape, So now in our shapes collection, we have one shape. And it is indexed at 0. Well, good times. You are joining us as we're transitioning from getting our rendering tuned up to use multi-meshes, which was after we changed our entity handling to have its own thread, to now getting our collision handling divorced from the direct movement handling. It's still happening in the physics tick, but because the entity movement physics is so expensive, we've threaded that off. So collision can technically be async there. A multi-mesh is a rendering entity that collects a whole bunch of meshes like a texture, that kind of thing, or a shape or similar, so that they can all be rendered at once efficiently. Okay, so we connect that. If we ever go in here, so if you watch, all of the mice animate at the same time. That's because they're all the same sprite. The image is just rotated. Whereas the player in the center is a single one, and they are transformed to move left and right, to hold still, that kind of thing. We're working on having the bullets hit the blobs here. These are final sprites at the moment. Like, they're the sort of visuals I intend to work with, but their use case and exactly how they're functioning is still in test. Like, we're using them for test cases. It is very busy, yes. The visible ratio on screen is another thing that we're fiddling with. We could zoom it out, but I need to make sure that all of the handling addresses that properly. Like in the mesh renderer, in catalog, in load textures. That's correct. Then in render ready, okay, we need to let's get these separated out. Stream time is generally nap time. So this is something that I'm fiddling with here, is the sprite scaling multiplier. As to how big they should be. This inventory screen is also not necessarily final as far as where it's looking, or where it is. The number of projectiles is currently not a worst case scenario. We're generating 25 mice per second and about 1 blob per second. So each of these 6 rows, each of them is generating 25 at a time. We're trying to account for very high numbers of projectiles created at once. The primary limiters in that is frames per second is one. No, I wonder. Now, we'll revisit that in a moment. Must not be distracted. It is no longer drawing entities. And if we look in collision zone, let's make sure that everything's all attached. Okay. In its physics tick, or just a int in area set shape transform local area RID index Okay, so for each of the shapes still in it, we need to update their positioning too. Entity shape has a position. but it needs to be spelled correctly. Position. Position. Position, not positon. Yeah. We are colliding. And hey, Tass. Shapes. Shape index. I'll get entity shape index. Entity return. This is as shape index. Entity to return. To shapes. Index. Not owner. My favorite bit about Godot? I know, it works. Oh, and the people making it aren't evil. So far. That last part is time volatile, though. That's still true. Zone on collision. Temporary function. If it runs into something, go away. Okay, we are seeing collisions. The radius, I don't think, is right. The remove me signal, I don't think, is working correctly for the blobs. Oh, okay. That's because the blobs aren't... it's not a mutual collision. This should make them both go away when they hit now. Yeah. Well, we have collision working again. I think next stream we're probably going to be doing a heavy scrub down of the code. Definitely some issues going on there. Yeah. But we're back. We're back. Look at that. We've got about 1,500 objects. We're running at a solid 30 frames per second visually, and I'm not seeing any sort of really apparent physics tick issues. We do need to work on the radius of the objects. Right now, their hitbox is real tiny. Can I ramp up the number? Yes. We do have one anomaly that still lingers when we spawn a whole bunch of them, but here. Let's load positioners. There we go. 50 at a time. Womp. Look at it go. And that spirally hypnotic pattern. So we can see the physics start to hitch around here, and that's where we still need to refine that movement logic. And I've got it set to cap out at 5,000. We do need to make sure that there is we almost need to have a global clock. Like a global heartbeat that things can look at and say, the global heartbeat is where the delta comes from. That way physics doesn't start to fall behind and we don't get as much of a lurch, but it is what it is. Part of that is because, let me show here. So when we go through the physics process in the physics handler here, we only iterate at minimum delta. We don't use the accumulated delta. So, oh, this isn't right. Oh, that's because we use minimum delta elsewhere. So if we look at our actual entity update thread, we use minimum delta. So what happens is if the delta time has started to get really high, we're still only ticking at minimum. So the entities start to move slower than time has passed. You get kind of a dilation effect going on. That's to prevent there from being real lurchy movement. Because if time slows down enough, we don't want things skipping. It can create issues. So this way we just slow everything down. It's not great, but... Oh, we got error cases too. Let's run that and see if we get those errors. Error states can cause big slowdowns because, as far as at debug time. Doing anything to the console is super expensive. Here we go. Here we go. All deferred. Okay. Errors aren't ramping up. It's right about the 3,000 marker. You can see how they're mushing together more. The spawner is more aggressive about trying to create more of them than the physics cycle can handle. But like I said, that's where kind of a global ticker would be useful. Something that says, this is what time it is. Yeah. Yeah. Let's take a look here. Okay. Clean out a bunch of this here. This also makes the collision handling way more durable. So in entity, I'll have to verify that the blobs can actually be struck here. Hey there, Zara. Welcome. Interaction. Say damage type. Set to receive. Enemy take damage. Okay. Okay. The target is just sending the remove signal, which is different. Visible and... No, remove me signal should be getting rid of the entity manager side too. Right? Oh no, it doesn't. This is the thing that needs to subscribe to an entity remove me. Oh, entity. It's entity. We only really need to do this with remove entity. Okay, so we get a signal coming in. If we add it, we're going to say entities to add. Entity. Remove me. Act. entity remove me. On entity remove me, first we're going to disconnect. Why do I need to do that? Hello, Zane. Welcome. Welcome back. Breakpoint. Breakpoint. There we go. They're being culled, and we're not generating errors like crazy. So this number is the number of entities active in the world. We are getting entities punching through, though. Like, they should not be able to get through that. Something is wrong. This would imply that either their collision shapes are disabled or something. Call entity remove. Shape the collision when it gets removed. So this is possibly part of the problem here, is that maybe we're not getting these re-enabled properly. So we disable the shape. We re-enable the shape here. Let's test here. Okay, so collision handling still needs some work. What we're getting is cases where we should be getting collisions, but we no longer are. Let's get it back to that state. I want to see if it's reporting collisions and doing nothing with them, or if it is not reporting collisions at all at that point. Doesn't help that the hitbox of the mice is very, very tiny. Pause real quick. Then we're going to go into collision zone. We are getting collisions. And we are sending the signal. Checking. So much going on. And base interaction. Image type. We are just in base entity at the moment. Go into the receive of enemy take damage. Is -1 health. They should be getting removed. So there's some circumstance where the removal isn't triggering. All right. I think that's going to be a problem for future Newt. We're going to wrap up there. But lots of progress today, lots of progress. Further cleanup on the physics handling. We finished up getting the animation in place again. So we have faster physics handling, we have faster rendering, and now we're working on the collision handling. There's still a couple of bugs in there, but we've got to be close. Hello, normal. So are you a teaching student, or are you just a regular student? Obscure fact. For those that aren't aware, a school for teachers used to be called a normal university. Robotics is channel relevant, at least visually. Oh, but lots of progress. Don't have, as per usual. I don't have the next stream scheduled yet. Haven't decided when programming will be next. I do want to get a game in there. Like I've said, we've still got to get through A Little to the Left, the new content there. We've got to try the Alice in Wonderland stuff and Power Wash. And I've had at least one thing suggested that sounds interesting. So we've got a lot of potential games on the horizon. But of course, there will be plenty of programming time. I want to thank everybody for swinging through today. I hope you had a good time looking over multi-meshes and simple shaders in Similar with us today. If you like what you saw and would like to see more, remember to like, follow, subscribe, all that good stuff. It helps the channel, and it will help you find stuff like this in the future. Make sure you set for notifications on YouTube if you do want to get notified of coming streams. It can be flaky that way. With all of that said, I hope the rest of your day is good, and I'll see you next time. Goodbye, everyone.